Okay, guys, I know you thought that, man, we got a sub, we don't have to deal with Miss Beardsley, but sadly, yes, I'm still here. You have to deal with me. It's fun and exciting. So, your job today, we are working on section 6.5. Okay, section 6.5. This is graphing linear inequalities. So we already know about inequalities. We've played around with them in the past. We had things like x is less than 6. We also had more complex ones where we had maybe 8 is less than 4x plus 1. Things like that. It got nice and complicated, and you guys had to graph those on a number line, and you used circles to mark those points and lines in the direction of the inequality and all that jazz. It was nice and fun and exciting, and all of you guys did incredibly well on the summative assessment or the trimester assessment when it came to that information. Now I get to blow your mind today. Essentially, what you're going to be doing now is, instead of just doing basic inequalities of the x is less than 6 plus 2 or whatever else, instead you are going to be doing more complex ones when we're dealing with linear equations. In this case, we have this situation. It says, tell whether the ordered pair is a solution to the linear inequality. That means this right here shows us a line, but it's not just an ordinary line, it's an inequality. So that means solutions that are on that line are not necessarily, or numbers that are on that line are not necessarily meeting that line. They're not necessarily solutions for that situation. So our job is to take this ordered pair and put it into here and actually figure out that solution. So we have a 4 for our x, so we can write a 4 in there for our x, plus 1 is, all that needs to be greater than our y, which is 5. So let's do the math work here. We have 5 is less than 4 plus 1 is 5. Is 5 less than 5? No, it is not. So this solution set, this ordered pair, is not a solution. Let's practice another one. Over here we have 1, 1 as an ordered pair, and we need to tell whether that ordered pair is a solution to the linear inequality. And again, here's my x value 1. I'm going to place that into my equation. 1 minus 7 is less, or is this time the y needs to be greater than that amount. So 1 is greater than 1 minus 7. Let's do the math work. Let's figure out the tough stuff. 1 minus 7, that's going to be negative 6. Is that all that is less than 1? Do we agree? Yes. 1 is greater than 6. 6 is less than 1. 1 is greater than 6. 6 is less than 1. That works. Okay, so this is a solution. It is a solution to this particular inequality. Exciting. That is the first couple of problems for your homework. This next couple of problems, let's go to a different part of our screen now. All right, this next part of our problem, we actually have to learn how to graph these babies. In all reality, let's look at this inequality. We have y is less than 3x plus 4. We can easily think about this as being the line y is equal to 3x plus 4 instead of y is less than 3x plus 4. I think I said that the wrong time the first way. Y is less than 3x plus 4. Sorry. So we're going to think about it as actually being this equation. Y is equal to 3x plus 4. If I think about it as this equation, this is easy peasy to graph. If I think about this, this is in slope-intercept form, so I have y is equal to mx plus b. My b is my y-intercept, and my y-intercept is 4. So I'm going to find that on my graph. 1, 2, 3, 4. Here is my y-intercept, kind of, sort of. There's my y-intercept, and now I have a slope of 3. Slope of 3, let's rewrite that as a rise over run situation. We have 3 over 1. So now I can go essentially up 3 and I'm going to go to the right 1, and that is where my next point is. I can then go up 3 more, find my next point of 1. I can even go backwards from my initial y-intercept, and I say I could go down 3 and to the left 1, and that's also a point. So now let's see if I can graph this properly with this whole Explain Everything app. It's awesome, but I don't know if I can be that accurate. Here we go. Ooh, I did a good job. That's awesome. Let's see if I can do the good job from the bottom part. Kind of. So there is my line. That is my line of y is equal to 3x plus 4. Now, we need to take this same concept of a line, but in this case, we have this situation happening. Watch carefully what I do. I need to show this inequality somehow. I need to show this less than sign somehow. And this inequality tells me that if I were to choose a point of, say, 0, 0, I need to determine if that information would actually be a solution to this. As well, I need to also see, would a point on that line, would 0, 3, essentially the point 0, 3, or 0, actually I should say 0, 4, that's going to be a point on that line. Would 0, 4 be a legitimate answer to this line? So let's look at it. We have y is less than 3x plus 4. We first need to graph it. Let's try to graph it nice and accurately like I did the last one. So I'm going to graph this baby. I think I almost got it. Oh, I'm pretty good today. That's awesome. I know you guys are giggling right now. It's fun and exciting. And the way I'm going to show this inequality information, I'm going to actually show this as a dashed line. Check that out. That's mainly, I'm showing it as a dashed line. That bottom part was bad, sorry. I'm showing it as a dashed line because we have a less than sign. If we had a less than or equal to sign, that would be a solid line. And we'll talk about that with your graphic organizer in a second. Feel free to pause this video at any point in time, by the way, if you are ever getting confused, and back it up and listen to it again. Okay, so let's go back to this y is less than 3x plus 4. I've graphed this line. Now my job is I need to figure out where this line, or what part of this graph is actually representing this information right here. This y is less than 3x plus 4. So let's first of all choose this point 0, 4. It's on the line. Let's prove to ourselves why this line needs to be dashed and not a solid line. So if I put that information in, we have y is less than 3x plus 4. I am going to add 0 in for my x. So I now have 3 times 0 plus 4 is, all that would be greater than my y value of 4. So let's look, is 4 less than, that translates to 4. Is 4 less than 4? No, it is not less than 4. It's equal to 4. 4 is equal to 4. And since this is 4 less than 4, not 4 less than or equal to 4, I need to have that dashed line. So now let's actually pick a point. Let's pick 0, 0. And let's see how 0, 0 satisfies this equation. We have y is less than 3x plus 4. We're going to put zeros in for our y's and our x values. And if we do all that work, we have 3 times 0 is 0. And we'll end up with 0 is less than 4. Is that true? Yes, it is. So this is how I'm going to finish off my graph. I am going to shade in all this stuff on this one side of that line. If I were to actually, I'm going to erase this. I'm sorry, I'm going to erase our awesome math work. I don't want you to do that on a regular basis because I need to see your math work. But if I erase that math work, I can see my completed graph. And I have a graph where I have the line y is less than 3x plus 4 shown right here. Okay, I can see that. Then also, what I can see is I have the area shaded below that. And that would be a completed graph. Okay, I know I blew your mind. I'm going to blow it just a little bit more, but hopefully this will help you a little bit. Let's back up and we are going to look at our MISN. So I want you to pause the video And I want you to get out your MISN page that says Graphing Linear Inequalities, and we're going to go through the few steps. So, pause. Press it. All right, so now we're back. What I'd like you to try to do now, you have your MISN page. Your first step for your MISN page, for this first number 1 spot, I want you to write in here, solve for y. Essentially, you need to get your equation into that slope-intercept form, that y equals mx plus b. One thing that you need to pay attention to is we are dealing with inequalities. So if you remember from before, when we were dealing with inequalities, when we multiplied or divided across the inequality, so if you divided y by a negative number or x by a negative number to make y positive or whatever else, if you did that, if you multiplied or divided by a negative number, you needed to flip, that was a bad L, flip the inequality sign. This is so crucial to remember. Remember, if you have something like this, x minus y is greater than 3. We would subtract x from either side. That's perfectly fine. We don't need to worry about flipping the sign. But I have a negative y is less than x plus 3. I would then need to divide by a negative 1 on all of my terms. So I have y is, I'm flipping the sign, check that out. That was some smooth sailing. And so I have x minus 3. All right, I flipped the sign. And remember, we do that, otherwise we have something that is untrue, and that is a problem. Okay, so next step. So for this next step, the next thing that I need you to add into your step number 2 is the following. You need to graph your information using the x and the y intercept, or the slope and the y-intercept. Graph using m and b. So essentially you would start at your y-intercept, and then you'd rise up or lower down and go left or right and that sort of thing. And you would graph it just like you would a normal line. This is the next tricky part. Okay, your next step, your step number 3. You need to decide if you have a solid line or a dashed line. Now this part is tricky, but in all reality it's not. I'm going to give you a little hint here. Let's look at these boxes. It says solid line and dashed line. Solid line, these are the symbols that you would want to see if you have a solid line. You would have a greater than or equal to sign, a less than or equal to sign, or an equal sign. That would mean you have a solid line. If you have a dashed line, you're looking at a greater than sign or a less than sign. Listen to that. I did not say equal to with either of those. So solid line, you have the equal to portion. With the dashed line, it is not equal to anything, okay? It's just a less than or greater than. Last step, you need to shade. This essentially tells you that you have completely understood what the graph means. If you have a less than or equal to, then you would shade in a certain, or you would shade underneath your graph. If you have a greater than or equal to, you would shade above the graph. So let's look at this box now, and let's write down all the information that you have. To shade above, you need to have a greater than sign going towards your y. So essentially you would see y is less than, or is greater than, or y is greater than or equal to. You'd see those two things. If you needed to shade below, you would see a less than sign, and you would see y is less than, or y is less than or equal to. All right, and that's when you would shade below. like I said before, I want you to put this information now into this starred region. Remember to flip your inequality sign when you are multiplying or dividing by a negative. Okay, that is so important. Do not forget that. That is going to be one of our biggest downfalls. So now let's go through the example problem. We have a graph. We have 2x minus 3y is less than 12. So going through that example problem, first step, we need to solve for y. We need to get into y equals mx plus b form. And we need slope-intercept form. So I'm going to subtract 2x from both sides. And I end up with negative 3y is less than negative 2x plus 12. Awesome. Next, I need to divide by a negative 3. Ooh, it looks like we're going to have fractions going on. That sucks, but oh well, we can deal with it. We're big kids. So now what we have is we have that y, which is awesome. We need to flip our sign. So we did have a less than sign. Now we have a greater than sign. Really fun. And now we have 2/3 x minus 4. Okay. I'm going to rewrite this so I can really see it really well. We have y is greater than 2/3x minus 4. And what we can do now is we can graph it. I'm going to graph it in red down here so we can see it pretty well. I'm going to go down negative 4. And I'm treating this just like it was y is equal to 2/3 x plus 4. Makes it a little bit easier for me to think about. So I am going to first find that y-intercept, and then after that I'm going to go up 2 and over to the right 3 units, up 2 units, over to the right 3 units, and essentially make this line. I'm also going to go down 2 units and over 3 units to the left, because if I do that I can kind of see my line better. I can see it developing. Now, before I start actually drawing my line, I need to decide if I'm making a dashed line or a solid line. I see right here, this is just a greater than sign, so therefore that greater than sign tells me that I need to make a dashed line. It can't be a solid line. So I'm going to start making that line. Nice little dashes. How exciting. Thrilling. Alright, so there we go. We have our dashed line that's been drawn. That's awesome. Last but not least, we need to figure out if we're going to be shading above everything or below everything. We can do this one of two ways. We can pick a point on our graph. Easy point to pick is always 0, 0, unless it lies on our line. So if 0, 0, if our line doesn't go through that point, 0, 0 is an awesome one to pick because we can essentially say, okay, I'm going to put 0 in for y. It's greater than 2/3. Put 0 in for x. Oh my goodness, I already got rid of that fraction. And I have minus 4. So I essentially end up having 0 is greater than negative 4. Is that true? Yes. Awesome. So I know I'm going to be shading above. Another thing that I can look at is if I look at this greater than sign, it's the same sort of thing as before. We can use these little cheat sheet sort of boxes. Greater than signs means I'm going to be shading above everything. So I'm going to be shading all of this area. Essentially, any value, any x and y value that is in that shaded region is a true statement for this inequality. That's what we're going for, and that's what our focus is for this. Hope this helps. Start your homework and have fun. Remember, you can always come in early morning and work in the classroom as well. Email or text me or call me at any point in time if you have any questions. Talk to you later, guys. Ciao.